Welcome to Practical Electroacupuncture. This is a continuing education class being offered through the College of Acupuncture and Oriental Medicine and the Continuing Education Department at Northwestern Health Science University. My name is Steve Compton. I'm a professor at the university, and I've been teaching this class to undergraduates and graduates for some time now. So we decided to make it an online presentation to see if anyone would be interested in that. One of the reasons I wanted to make this, that really motivated me to come up with this class, is ran across this quote by Richard Niemzow. "We must avoid being appliance users. Our interest in these instruments must be more than just the knowledge of how to turn them on and off. If we continue in the present manner, we risk compromising our patients and our research." This is in regard to electroacupuncture. He was writing back in 2002 in Medical Acupuncture, a journal of the, I think it's the Academy of Medical Acupuncture. These are the MDs that do acupuncture, and I have a lot of respect for Dr. Niemzow, and his opinions on this, I think, are something we should take into account. There are a lot of other reasons why this class needs to be here, though, and one of them is that electroacupuncture is one of the most effective and heavily researched acupuncture modalities. Many people learned a little bit about it in school, but didn't get enough to feel comfortable once they were out to use it. Also, student clinical experiences in electroacupuncture are often limited, sometimes by the fact that their clinical supervisors don't like to use electroacupuncture. So if you got a lot of good experience in school, you were one of the lucky ones. If you didn't, this class should help you. Because a lot of people wind up in practice, maybe even owning a device and not feeling comfortable using it, lacking the clinical experience and confidence to go forward and use electroacupuncture. So let's talk about what it is. Broadly speaking, electroacupuncture is any procedure based on measurements or therapies combining acupuncture theory, points, and meridians with modern electronic instruments. So you see a variety of things out there on the marketplace. We'll talk about some of them later, but everything from lasers to electromagnetic pulse generators, point detecting instruments, all kinds of things. That's a broad definition. We are not going to use that definition for this class. We are going to focus on this: electrical stimulation of acupoints through acupuncture needles. This is also called percutaneous electrical nerve stimulation. So we're going to be talking about using the basic standard electroacupuncture devices to stimulate needles. And this is a question, pardon the funny graphic, this is a question that does come up. Is this a natural thing to use electricity in a what is otherwise an ancient natural healing modality? So I always like to sell this a little bit to you. Electricity and electrochemistry are part of nature, and it's really involved in many aspects of life. Pretty much anything that has life has some electrical activity. Everything from plant photosynthesis to the very complex neuronal networks of the human central nervous system. You learned in your anatomy classes that at the cellular level there are charged ions that create a different in voltage potential between the inside and outside of a cell wall, and this is what drives, the calcium and potassium and to inside and outside of the cell at the cellular level. And then you have the same membrane potential drives cellular metabolism. It gives cells the ability to send messages through the body. So there's a lot of, starting at the very cellular level, electricity is involved in all the signaling that our nervous system does. Human bioelectricity, the heart and brain generate the strongest electrical signals in the human body. And these are measured by scientific methods using electrocardiograms and electroencephalograms to diagnose cardiac and brain diseases and disorders. And you see these in, most hospitals have these kinds of setups. to do testing and monitor patients' health. The power of bioelectricity, the electromagnetic field generated by the human heart, is so powerful, in fact, that it can be detected up to several feet away by sensitive electromagnetic frequency detection instruments, and sometimes people say they can detect it. I'm not sure if that's a very subjective thing, but some people say they can detect the presence of other human beings. But there is a magnetic field there, and so it is possible, I suppose. Certainly instruments can detect it. So is it natural? I say yes. It's all around us. It's in nature. It's inside the cells of our bodies. And it's another tool that we can use in natural healing. History of electrotherapy. Human beings have been using electricity to treat disease and pain for thousands of years. This is not as new as you might think. We think of electricity as being a fairly recent phenomenon, but actually it's been around for years. And how has it been around? Well, there are animals that generate electricity inside their bodies that are so powerful that human beings can be shocked by them. And among those are electric catfish. So there are hieroglyphs in Egypt showing representations of these electric catfish. And there are stories from that era and also from the Greeks about using electric catfish to relieve pain, much as we would use electrotherapy today to relieve pain. Of course, catfish can't be modulated or contained, or they're not that portable either. So they're not very useful in a modern clinical setting, but there's evidence of this going way back, the use of electricity, especially for pain. Then let's jump forward to the modern era, and we have what we most of us know the story, Ben Franklin flying his kite, experimenting with electricity in many ways, kind of a Renaissance man. He tried to treat seizure disorder, which I don't think worked at all, but at least he was trying something. And around the same time that Franklin was doing this, we had this gentleman, Janai Hiraga in Tokyo, using static electricity to treat spasms and paralysis. This is more the kind of thing we would think of today as a use of electrotherapy. In the 1820s, there was a French gentleman that coined the term electroacupuncture and was using it to treat gout and arthritis. He was using more, acupuncture came to Europe fairly early in the 19th century, so people were using it, especially in France and Italy. And this guy got the idea of using batteries, I think, to use with the acupuncture needles, and tried treating gout and arthritis. Probably was effective. He coined the term. There was a book published in 1834 in Italy, and then in 1844 we have records of electroacupuncture being used to treat sciatica and lumbosacral neuralgia, again, something we would probably do today. 1878, Rudolf Arndt treats paralysis and depression with electrical currents. Again, very amenable to electroacupuncture, these conditions. So, there's a lot of early evidence of electroacupuncture being used. However, the machines were not reliable, they weren't mass-produced, they weren't testable in many ways, and so it didn't really spread much beyond the individuals who invented their own machines and used them. So in the 1800s and 1900s, there was a lot of interest in electricity. And so many questionable electrical devices were used throughout Europe and America to treat a variety of ailments. And I'm going to put up a couple of pictures here of who knows what these instruments were. They were doing different things, and they were using electricity to try to treat a variety of ailments. There's records of people actually dying, being from electrocution from using some of these types of devices. But it was something of great interest to people, and they knew electricity had a lot of potential, and how it could be used in medicine was very intriguing to people. But because of all of this, and probably because of some of the deaths, there was a backlash against electrotherapy. And in 1910, there was the Flexner Report, which was, I believe, funded by the Carnegie Foundation, and it declared electrotherapy to be unscientific. Along about the same time that homeopathy and other non-allopathic medicines were being attacked, electrotherapy was lumped in with those and was discounted. So we had a banning and, I don't know if it was banned outright, but at least it fell into disfavor. It was questioned. And at the same time, there were some people who had used electrotherapy, had some devices they thought were effective and were using it and continued to use it. Some MDs, some osteopaths, and some chiropractors. In 1934, the first Chinese book on electroacupuncture was published by Tongshi Chen, and this was in China, of course, but of course in the 30s, China was undergoing great upheaval. There were wars going on, civil war, and not much happened with electroacupuncture in China because of that. In the 40s, we had a German MD, Reinhold Volt, using electrical resistance testing of acupuncture channels for diagnosis and treatment. He called this electroacupuncture, according to Vol. Here's a picture of Dr. Vol. He's doing the meridian testing procedure that he has. Now, yes, the electrical resistance of acupoints tends to be lower than other parts of the body. However, using this diagnostically, I think, is the questionable part, and no one has really determined if treating the resistant points and seeing if there's a change has any real effect, and that has never been proven scientifically. So, though there are a number of devices out there, Volt-type devices, there's not a lot of science behind it. Same idea occurred in Japan to this gentleman, Nakatani, and he may have known of Dr. Vol's work and just replicated it, I'm not sure. But he claims that acupoints have lower electrical resistance and calls it this Ryodoraku, good electric conductive line. So he determined that these were good lines to treat if they had lower resistance. Picture of the married gentleman here. And then in 1953, Vol developed the first electroacupuncture device, along with some colleagues in Germany and France. And in 1958, we have the first record of surgery using electroacupuncture analgesia in China. So there was a rapid development post-World War II of electroacupuncture and its use around the world, really, in Europe and in China and Japan. 1972, of course, everybody knows, members of the U.S. delegation visiting China with President Nixon observed surgery with electroacupuncture. And this was kind of a revelation to people that acupuncture could be used as part of surgery. Now, this was, I think there was some misapprehension about everything that was going on with this surgery because it was not just acupuncture analgesia, but they were also being given sedatives as well. And here's a picture of a postage stamp from that era showing the acupuncturist here on the left using an electroacupuncture device on a little cart, and the patient is getting surgery here. This is, I think, this is commemorating a famous surgery that took place in the 70s. 1974, we had the first portable TENS unit patented in the United States. We'll talk about why this is important later. TENS is transcutaneous electronerve stimulation. 1979, Chang and Pomerantz published a paper on the mechanisms of electroacupuncture analgesia and how it works, what the basic science behind it is. 1985, Robert Becker's book describing the current of injury and the electrical properties of acupuncture points was published. A great medical memoir that describes his discovery of this and confirming the lower resistance that exists around most acupuncture points. 1988, the FDA grants this first acupuncture device status in the United States, and that was called substantial equivalent status. We'll talk about that later as well, but this goes to the first device was the EDO IC 1107. This was a little EDO, we call it sometimes, a very small TINS unit really that was adapted for electroacupuncture, and it's still in production today and still basically looks just like it does there in the picture. And once this little device hit the market, a bunch of other devices followed, and since the 1990s, around 1990 to the present, electroacupuncture has been used in the treatment and research all over the world, China, Japan, Europe, and the US. It's become very common, and in fact, in most research, you're going to find that they're using electroacupuncture. So who regulates this? Who approves these devices? This is important to know. This goes back to Niemzau's point of we should understand what we're using. These devices are, in fact, regulated by the FDA. The Food and Drug Administration has the authority to regulate all medical devices under the Federal Food, Drug, and Cosmetic Act. There is currently no separate FDA device category, however, for electroacupuncture devices. They do have something called the 510K rule, which allows electroacupuncture devices to be approved as substantially equivalent to TINS devices. If the TINS device was approved before 1976, or basically if any device that was approved before May 28th, 1976, if you can say, okay, what I'm getting approval for is substantially equivalent to that device, then you can get approval for your device. Now, of course, this is what electroacupuncture devices that are now sold in the United States have been doing. They've been getting this substantially equivalent status. And any device that you're using should have an FDA approval, and they should have documentation of that approval. You should look for that. However, and here's the code, just so you have it. It's in your notes as well, so you know where this is regulated. Again, there's no separate category for electroacupuncture devices. They are regulated under the code for neurological devices, and under that, the subsection for transcutaneous electrical nerve stimulators. So, important to keep in mind that the FDA does not test these devices to make sure they do what they say they will do. They look at them, they look at their specs, and they say, okay, this looks right, this looks like it's doing this is a TINS unit, it's doing electrical nerve stimulation, that's what it's designed for, and then they pass it on. They don't test the devices in a rigorous, like a Consumer Reports or a lab test, to make sure that all the frequencies are right and all the intensities are within the bounds they should be and the waveform is correct and all of those things that require scientific instrumentation to test. FDA doesn't do that. So who does do that? No one's doing that. And that's a problem for our profession, I think. That's a problem for the devices that we use. We have to be very careful in choosing those devices to make sure that they're of a high enough quality that they're safe to use on our patients. We shouldn't just be going out and buying the cheapest device we can find. The last comprehensive independent test available of electroacupuncture devices was done by Lytle in 2000 and by Niemzau in 2002. These were two separate tests that were done. Lytle examined 3 devices, 2 from Japan, 1 from China. Niemzau examined 6 devices, including units from Japan, China, and at least 1 from the United States. The one I kind of figured out was a Pantheon research device. I think he examined a couple of EDOs and some of the Chinese devices. Their conclusions were a bit disturbing, and I've got references here to both of these articles if you want to go look them up. And it's enlightening to read these and find out what they did find, but I'll summarize it here. So Lytle's study, his conclusion was, for each device, at least 2 measured parameters were not within 25% of the manufacturer's claimed values. The most bothersome aspect of the poor precision of the stimulator outputs is recognition that most of the data in acupuncture literature were developed from experiments that employed similar devices. So he's saying, this makes us question some of the research because the devices are not accurate, and yet the data is relying on those devices for their treatment parameters. Lytle recommend better characterization of experimental devices is required in the future, perhaps by following guidelines used in this study. So he laid out some guidelines for what kinds of tests should be done. Tests should be done to determine device safety and efficacy. Now, Niemzow's study was probably a little bit stronger even because he tested 6 devices, remember, and he found the frequency error ranged from 0.1%, so less than like 1/10 of 1%, which is pretty low, to over 50%. So some of the devices were way off in their frequency calibrations. And he says these thresholds are not acceptable for either clinical or research utilization. He recommends an annual review of stimulator quality, sponsored, published, and thus made available to practitioners, that all acupuncture stimulators meet the precision and calibrations requirements of the National Institute of Standards and Technology. He was trying to prod government to get involved in doing some testing. Now, Niemzow was an Air Force colonel, MD, who did acupuncture. I think he's since retired, but he did have a lot of clout at the time he was making these statements. Unfortunately, though, nothing has happened. To date, there are no testing agencies involved in testing electroacupuncture devices. So what can we do? My recommendation is you only use reputable devices from well-known manufacturers. This is really the key. You have to have a manufacturer you can trust. You have to make sure the device you're using is FDA approved. Make sure you understand how to use the device. I can't tell you how many people I've seen who don't really understand the device they have in front of them. It's a box. It's got some knobs on it. They turn it on and they hook it up to their patient, and they don't really understand how it works. And they may not even understand how all the controls work that they're using. Test and practice with any new device. This is important. If you get an acupuncture device, if you have one already, I highly encourage you to try it on yourself. See what it's like. Try the different parameters, turn it up, see what happens, see what the different frequencies feel like. And then remember that electroacupuncture research is only credible if it uses pre-calibrated devices. So if you're reading a research paper that cites electroacupuncture as the modality they're using, you need to remember that they also need to cite what device they used and whether or not the device was calibrated prior to being involved in the research. Because that is extremely important to know that the device is really performing the way it's supposed to perform. So if they're saying we use this frequency, this modality, and we used it at this intensity level, you need to know if those were actually true, that they had pre-calibrated the device to know that they were getting out of it what they thought they were getting out of it. Device safety is extremely important, and really making sure you have a good device is extremely important. We're going to talk later about different kinds of devices. I've studied the 2 studies that were done by Lytle and by Niemzow and determined, kind of to my own satisfaction, what I believe they were looking at. Although they don't name the devices, I'm making suppositions based on the parameters of the devices they tested. But it looks to me like, I'm going to show you some devices later, and I can kind of point out which ones I believe they used in their tests. So here's another question. Is all acupuncture electroacupuncture? I think there's some electrical activity that happens, again, in the body. And certainly when you start putting needles in, a lot of things happen. Many acupoints have been found to have a lower electrical resistance than the surrounding skin tissue. This has been found by on back in 2008 and confirmed this along with a bunch of other researchers. And it was published in Bioelectromagnetics. But this idea has been around for a long time, going back to Voll, Nakatani, Becker, and others have found this same phenomenon. There's been a lot of debate about how to use this phenomenon that has lower electrical resistance. What does it mean? I think the only thing we can determine that it means is it helps locate an acupoint. Do differences in electrical resistance mean that we should treat this point and not that point? I don't think so. I don't think that there's no proof of that. And if you get 2 points to balance out to have the same electrical resistance, does that change the health of the patient? There's actually no proof of that either. So I think there's a lot of speculation, and there are devices out there that find the point electrically and then try to treat it, but there's just no evidence that that has an effect beyond actual point location. Acupuncture needling by itself activates various electrical effects. There's a nerve signal that's sent. There's a current of injury that Becker talks about. There's electrolytic effects with different metals passing through different kinds of tissue. And then there's the piezoelectric effect. When you compress liquid crystalline structures like connective tissue, it releases a charge as well. So there's various ways that acupuncture itself generates small electrical signals. We're talking about in the microcurrent, the nanocurrent level of electrical signals, but there are small signals that are released. So how does this work? How does electroacupuncture work? According to acupuncture oriental medicine theory, how does it work? It's not in the Neijing, it's not in any of the ancient texts. They don't talk about electroacupuncture devices. It's a new thing. But we know that from experience, it does kind of the same things that acupuncture does. Stimulates the movement of qi and blood. Can reduce stagnation and stasis, or it can tonify, and it can tonify as well. It can tonify or reduce, really. And so it has a lot of potential to do the same kinds of things that acupuncture itself does. Biomedical theory tells us that it activates sensory and motor neurons, that it activates a range of neurotransmitters which reduce pain and inflammation. It increases cellular ATP. This is microcurrent does this. We'll talk more about some of these things as we go through this, but I think it suffices here to say that according to both acupuncture theory and biomedical theory, electroacupuncture can do a bunch of things. Why would you want to use it? It allows for a stronger and more continuous stimulation with less risk of discomfort and tissue damage. I think this is the biggest reason that I was drawn to electroacupuncture and that many other practitioners wind up choosing electroacupuncture. If you're working with intransient conditions, chronic pain, paralysis, things that are pretty difficult to treat without a lot of strong stimulation, electroacupuncture can be a great choice to speed up the recovery and to allow for actually more comfortable type of treatment than manual acupuncture with manual stimulation. It can also, on the other end of the spectrum, allow for a lighter, less invasive stimulation. You could use, in addition to attaching it to needles, you can use with pads or probes, like a TINS unit, or with probes to treat, which are also using TINS, basically. It's still transcutaneous, using probes to treat points. And this can work really well for people who are needle phobic, for children, and in certain situations like using facial treatments and things like that. It may be more effective in some situations, and this again gets back to my first point, chronic pain, paralysis, neuropathies, things that are difficult to treat and are not responding to regular acupuncture. It's less time consuming than manual needle manipulation, and it's more easily controlled, standardized, and measured for treatment consistency and research purposes. And then there's this. There are billing codes for electroacupuncture. As you know, if you're billing insurance, there are 4 CPT codes for acupuncture. 97810 and 97811 are for manual acupuncture. The other 2 are for Electro. So 97813 and 97814 both are for covering electroacupuncture stimulation. Now, you know, some people do charge more when they're billing electroacupuncture codes. Some insurance companies will pay more, not all of them. But it's worth exploring. I think it's certainly worth coding it correctly when you are coding it, so that the insurance company knows what you're doing. And if it comes up later, you know, if there are any questions about it, then it's recorded that you did what you did. And your parameters, you should also be recording those. So let's get technical here. I know technology is not a favorite subject for most acupuncturists. A lot of people come to acupuncture, in fact, because they're trying to get away from Western medicine, the technological approach to treatment. You know, I like this slide, the left brain, right brain slide. And I think there are acupuncturists who kind of are dominated by one side or the other. And hopefully we can all try to get balanced somewhere in the middle. And you know, acupuncture is both a creative and a scientific process, and so I think we can do both. And how do we get there? You know, what's the way to bridge that gap? I think the common ground is really language and terminology. This is where, again, back to Niemzow's quote, we need to understand our tool. If you know you're using an acupuncture needle, it's a very simple tool. It's just a little thin piece of wire sharpened on one end. And it's probably the simplest medical device ever approved by the FDA. On the other hand, you know, we're using, and then we use things like heat and cupping and gua sha, or our own hands, using tuina or shiatsu or other bodywork techniques. However, you know, when you're using electroacupuncture, you're using a modern electrical device. It has a battery, or it plugs into the wall, has a bunch of controls on it. You have to know what you're doing when you use these devices. So it's important to spend some time learning them. It's the only really technical device we have that has a lot of electronic gizmos hooked up to it. But believe me, if you can use a computer, if you're using, you know, electronic health records on your computer, you can use an electroacupuncture device. If you spend all that time learning to use a computer program, you can spend a little bit of time learning how to use the electroacupuncture device properly and understanding what it's doing. So terminology is the first piece of this. We're going to spend a little time on some basic electrical terms. Then we'll jump into some electroacupuncture specific terms. But I want you to understand kind of the basics of what we're doing when we hook up these devices. So the first term we're going to talk about is current. Current, you know, we talk about, well, the current of the channels, the energy is flowing through the channels. Well, it's kind of the same concept for electrical current. Current is flowing through a pathway. The pathway goes from a negative source to a positive source. This is a flow of electrons that's established through this pathway. This is important because this is what creates the felt intensity of the electroacupuncture treatment. So the more current you're putting through the pathway, the more the patient's going to feel it. The pathway of the electrical current, and you can hear, this is a simple diagram of a simple current. You've got the battery, and then out of the battery comes a charge which goes from the positive, or from the negative side. There's a switch here that's closed, and then it goes to around the circuit. It lights up the light bulb, it does some work, and then it goes back into the positive side. So that circuit circling around is what makes up this electrical circuit, and the work is done in the light bulb. So here you can see a similar concept. We've got the battery is encased in your electroacupuncture device. You know, you've got a circuit hooked up and then plugged in, and there's actually 2 little wires coming out here, and it goes around and it comes in and it goes to the negative and then through the patient. So the light bulb is here. in the patient's body. The patient is where the work is happening, and then it goes back on the positive side. That's the electrical circuit through the patient. So polarity. Talk about negative and positive here. All electrical circuits have a negative and a positive. There's a black. Usually black is representing the negative, red representing the positive. And current flows from negative to positive. And there's a little representation of that flow. This would be called monophasic polarity, current always moving in the same direction. And a lot of early electroacupuncture devices were monophasic and did this. What they discovered, though, is that this causes some problems with electrolysis of the needles, and tissue necrosis would actually happen, because with the current always moving in one direction, you could get some loss of molecules from the needle on the negative end into the tissue surrounding that needle, and then it would cause some tissue necrosis, which is not what you're trying to do. You're trying to help this patient improve, not make them worse. So monophasic polarity was one of the reasons back when we just had batteries and direct current that people were not too keen on electroacupuncture, and one of the reasons that it probably delayed its development for a while until we discovered something else, biphasic polarity. So in biphasic polarity, what happens is that the current reverses direction at a set interval. I think in most devices it's around 3 seconds. It goes one way for 3 seconds and then goes back the other way. And negative becomes positive, positive becomes negative, and the current reverses. And so this continues to happen as long as the treatment's going on. This prevents electrolysis, and it prevents the breakdown of the needle, and it also prevents damage to the patient. And it's more effective. This is why it's important. Monophasic creates the danger of electrolysis, and here he explains it, and then biphasic current prevents electrolysis. Most of your modern electroacupuncture devices are biphasic. In fact, I think they all are now. And even the ones that have a little switch that says you can switch the polarity, they're basically just switching the waveform instead of the polarity. So the waveform, and we'll get into waveform later, but they're switching the direction of the waveform. So they're still maintaining this biphasic polarity. So how is electrical current measured? It's measured in amperage. It's a standard measurement of the amount, the number of ions passing, or electrons passing a given point in an electrical circuit. So, and so that's called amperes or amperage or amp. And the abbreviation is a capital A. So you'll see that used in a lot of literature for amperage. So remember, current equals amperage equals intensity. So as you turn up the current, you're turning up the amperage. You're turning up the intensity of what your patient's going to feel. Some common appliances have, amperage from anywhere from 0.5 amps up to 13 amps. So this is what you would get, for your light bulb or your power saw or your computer. You would get in this range, up to 13. I think most electrical circuits they will cut off if it goes above 15 amps. Some are cut off at 20 amps. So, you'd throw a circuit if you went above that, if you were pulling more amperage than that. But the devices we're using are talking about milliamps and microamps. So they're tiny, tiny amounts. You could not light a light bulb with a millicurrent device or with a microcurrent device. You can't have a lot of effect, but the patient can feel it. And so they're very safe in that way because they won't go too far. They won't shock the patient. They won't light them up. Another term is voltage, and we're pretty much all familiar with this. Most household currents are 120 volts. We know that that's a lot of voltage, and if you touch that, it's going to shock you. This measures the potential difference between 2 points. So this is, again, back to the cellular level. We talk about membrane potential. This is a difference between the voltage inside and outside, the potential for pushing that current through the cell wall. Well, in the case of electrical current, it's the amount of push behind the electrons flowing through the circuit. So the greater the voltage, the more current you have. Household outlets typically carry 120 volts. In Europe, I think it's like 240. And there are some circuits in this country that will carry that much for air conditioning and things like that. Most electroacupuncture units run on batteries delivering between 6 and 9 volts. And then they use various methods inside the machine to ramp that up, sometimes as high as 30 volts, but that's pretty high in terms of the power behind that. And then it's ramped down to the microcurrent level. So we don't get a lot, we get a lot of push, but not a lot of current out of this. And here's why you need voltage. You've got something called resistance. And various different substances have different amounts of resistance to the flow of electrical current. And this is measured in ohms. And there's the omega sign there, shows you that's the symbol for ohm. Now, ohms are, you won't see that sign very often, but we may talk about resistance later as well. The lowest resistance in substances is found in metals. Silver, copper, and gold are the very lowest in resistance. As you know, most electrical wires, in fact almost all, are made of copper. Some are aluminum, other metals, but these metals are chosen because they have a very low resistance to the flow of electrons. So you can pass a current through an electrical wire and it'll reach the appliance on the end with very little loss of that current. The highest resistance is found in things like plastic, rubber, wood, ceramic, glass. These substances, as you know, are often used to insulate electrical wires. So typically, your electrical wire has copper in the center with a plastic coating around it. Both household wires as well as the wires we use to connect our electroacupuncture devices. Water and other liquids has a tendency to lower electrical resistance. This is why if you stand in a bathtub and you hold a toaster, you're going to get electrocuted because you're in water. Anytime you're in water, your resistance goes way down. So anything that's wet has a lower resistance.